All right, SM3. This video, or SM3 honors, I guess, for this video. Um, Doing some dividing polynomials. Sorry to step too far forward again. So last year, SM2, you should have done add, subtract, and multiply polynomials. But I'm sure you were thinking, what about dividing? It probably left a bad taste in your mouth, right? I'm only 75% done, right? Well, I mean, technically there's more operations than just add, subtract, multiply, divide. That's the only ones we use in high school, right? In fact, you won't see the other ones unless you do some kind of math theory with theorems and things like that, proving theorems. Anyways, right, you're probably salivating, chomping at the bit right now because you finally get to divide polynomials. And it is so dang fun. All right? So let's just jump right into it. I hope you have your guided notes. If not, pause the video, get your guided notes out, because that's what I'm going to be following along with. Okay, let's do it. If you need, or if someone's never taught you, which I could really see, but if you need a refresher, if your vocabulary for dividing is rusty, right here. Okay, I'm going to put it up here also. This right here is called an obelus. It's not on here because most people, I don't say most people, I'll say most people in the world don't know what it's called. Yeah, even mathematicians, a lot of them don't know what it's called. Anyways, okay. This is called an obelus. It's our divide sign. Okay, this right here, we'll put, because our first example is the 5 divided by, or 678 divided by 5. This is called the divisor. This is what's doing the dividing, so divisor. Okay, this right here is called the dividend. That is what's getting divided into 5 equal pieces. Okay. This up here, our answer, when we do our division, our long division, is called the quotient. Okay, and when we do all of our long division, down here we're going to get a number that's not divisible by 5. That's our remainder. That's what's left over. Okay, now normally, I won't say normally, but a lot of times, you would go on and you would do decimal places, right? You put your zeros back here. We're not going to do decimal places because we're going to long divide polynomials, and there's no decimal places with polynomials, right? It's terms, there's not like a decimal. So we're going to have a remainder. I'm going to show you how to properly write the remainder too. Okay, now we have 2 different styles of division for polynomials. There's long division, which always works. That's why I love long division. It's my favorite because it always works no matter what. It always, 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 always works. And that's the one I kind of push on people. Like when in doubt, use long division. Okay. The other one is synthetic division. Now, synthetic division is nice and it's fun to do because it's quick and it's easy. Right? It's very quick and very easy to do. You don't really have to deal with any of the variables. But the problem with synthetic division, it only works in one specific instance. Okay, you have to divide by a linear binomial. Now, if you're watching this video and you thought, oh, I don't need to do any of the review from SM2, and you don't know what a linear binomial is, you need to go back and relearn or refresh on the vocabulary, okay? Because I use vocabulary terms. So you need to go refresh on that. So a linear binomial, okay, kind of like this. Binomial, 2 terms, linear. The largest exponent is 1, right? Degree 1. That's the only time the synthetic division works, is if you have a linear binomial. But long division, doesn't matter what you have out here. You can still do long division. Doesn't matter. That's why I like this one much, because it always works no matter what. But I will be teaching you both. The other big difference between long division and synthetic division, long division you divide by a factor. So remember last year factoring, which I hope you remember. If not, then come talk to me and I can get you some factoring review. Because factoring is probably one of the biggest things you learn in your high school math career that prepares you for your next math classes. A factor is something like just like this, right? That's a factor. You don't even need parentheses really. That's a factor. Okay. Long division, you must divide by a factor. Okay, you have to have that variable there because everything inside the dividend is going to have variables. Synthetic division, you divide by a 0. Okay, now hopefully last year you learned what a 0 is. A 0 is where the graph crosses the x-axis. It's where y equals 0. So in order to find the 0, you have to take your factor, set it equal to 0, and then solve. So negative 8 would be my 0 for that factor. Okay, we're going to get into this, I promise. It's just a little of prep work. Okay, and we're going to do this one real quick to remind you how to do long division. Okay, there might be some of you that have relied way too much on their calculators and have forgotten how to do long division. Okay, I will never. The only time I'll really use calculator in the class is if I'm running out of time. Okay, but I want you to see that everything is possible to do by hand. In fact, I recommend doing all your arithmetic by hand because it allows you to see patterns in the number, and that's how you start doing math more quickly. I guess I'll say doing math quick is not important at all. In fact, if you do math quick, you tend to miss things, but it helps you see patterns to where you can focus more on not adding, subtracting numbers, but on the actual. For example, arithmetic, how the division goes. Or when we're graphing, you can focus on the actual characteristics of the graph instead of having to worry about, oh, can I do 1/3 plus 1/4 kind of thing. All right, that's just a recommendation. You do not have to listen to me, obviously. Okay, let's do this one. So long division. Two ways of looking at it. You can say, how many times does 5 go into 6? Or 5 times what will give me closest to 6? Either way, I don't care how you look at it. It should be 1. Okay, now we do our multiplication. 5 times 1 is 5, and you subtract. So whatever you get down here, you subtract it. Okay, multiplication is a whole bunch of additions. Right? 3 times 2 is just 2 added 3 times to itself. So division is a bunch of subtractions until you get a remainder, or until you can't subtract anymore. So we're going to subtract 5 times 1 is 5. We're going to subtract it. We have, excuse me, 1, and then bring down our other numbers. Okay, now we're going to look at, we just did this, the hundreds column. We're going to do the hundreds and the tens. We're going to look at 17. Okay, so 5 times what gives me closest to 17? Or 5 goes into 17, how many times? 3. 5 times 3 is 15, and we subtract. 1 minus 1 is 0, 7 minus 5 is 2, or you can say 17 minus 15 is 2. And then bring down our last number. 5 times what gives me closest to 28, or 5 goes into 28 how many times? 5. 5 times 5 is 25. Subtract. We have 3. I'm going to box. I'll box the remainder always so you know which one's the remainder. Remainder of 3. Sorry, R3 is probably not a good way to put it. So 678 divided by 5 is 135 with a remainder of 3. Okay, and we're going to be using remainders. Hopefully that was not just a refresher, but it was kind of tedious for you because you're good with it. Okay? If not, then please practice. Okay. Now, like it says in the guided notes, I don't really have a good program on my computer to be able to type to show every single step of a division problem because you can't really get the indentations and things like that properly. I tried it. I promise I spent like an hour trying to do it. It's just not going to work. So that's why I have here in bolded, you need to follow along with the video. Right? You need to follow along with the video so I can show you how to do it. Okay, so we just did this one. We did this one right here. Let's go on to this one, doing long division. Okay, we're going to use the same principles. So, we're going to do x plus 2 divided by, no, sorry, I'm saying that wrong. X to the third plus 5x squared plus 9x plus 6 divided by x plus 2. Okay. Now you might be thinking to yourself, well, the other one was just a single number. What do I divide here? It's okay. You're going to take your leading term, okay, so your first term, and you're going to do all the, does it multiply into this, or how many times does it go into this kind of thing, okay? So we're going to take our x, and we're going to say, x goes into x to the third how many times? Or x times what gets me close to the x to the third? Or you can think about it, because now it's going to kind of divide a little bit more even than with just numbers. X to the third divided by x. Either of the three works. I don't care how you see it. However you see it is perfectly fine with me. Just please understand how we get to our conclusion. Okay. So I like to think of it as x to the third divided by x gives me what? X squared. Okay. X to the third divided by x. 3 minus 1. You should have learned this last year. If not, if you are rusty with it, then come talk to me. You need to practice some more. Okay. 3 minus 1 is 2. X squared. Okay, now we do the thing where we multiply back. Okay, so we're going to go x squared times x is x to the third. X squared times 2 is 2x squared. And then subtract the whole thing. Don't you dare only subtract this first one. Don't you dare. I will come and I will hunt you down. All right? Subtract the whole thing. So x to the third minus x to the third, that should give us 0. If you're doing it correctly, you're going to get 0 for this first difference. 5 minus 2 is 3x squared, and then bring down everything else. Right, and we get to do it again. So, 3x squared divided by x. 3x squared over x. 2 minus 1 is 1. So we have 3x. Or x times 3x is 3x squared. Okay, whichever way you want to think about it. Now back multiply. 3x times x is 3x squared. 3x times 2, 6x. Subtract the whole thing, right? Not just the 3x squared, the whole thing. You should get 0 here. 3x squared minus 3x squared gives you 0. 9 minus 6 is 3x. Bring down the last term here, your constant. Now let's do it again. Aren't you so excited? Okay, 3x divided by x is 3. Back multiply. 3 times x is 3x. 3 times 2 is 6. What do we do? I should have heard you shout so loud that I could almost hear you through the computer back in time saying, subtract everything. 3x minus 3x is 0. 6 minus 6 is 0. We got a remainder of 0. It factored perfectly. A little bit of foreshadowing for you, but it divided perfectly. Okay. And so here is your answer. X to the third plus 5x squared plus 9x plus 6 divided by x plus 2 is x squared plus 3x plus 3. If you don't believe me, look it up on symbollab.com. All right, let's do another example. Okay, this one will have a remainder, and I'll show you how to write the remainder. So we have 4r to the fourth plus 4r to the third plus 8r plus 3 divided by 2r squared minus 1. Now, before we do anything, I want you to notice we have r to the fourth, r to the third, and we skip r squared and go straight to just r to the first and then the constant. Right? So we skip r squared. Now, you can do long division just like this. It'll work. You have to be careful with your variables and you're combining like terms. You have to be very careful, but it will work. How I'm going to show it to you and how I'm going to teach it to you should help you not get confused and not lose terms in your polynomial. And if you get in the habit of doing it this way with long division, it's going to be really easy with synthetic division where you have to do what I'm about to show you. What I'm going to do is right here after r to the third, I'm just going to put a placeholder, plus 0r squared. Right? I didn't have any r squareds, so I have 0 of them. I forgot what the plus 3. Okay. I'm just going to create a placeholder. Now, in synthetic division, you have to have a placeholder. Long division, you don't. I'm going to show it to you like this so you don't get confused. Okay? Because it's easy to lose things, and it's easy to combine unlike terms if you don't create a placeholder. Okay? It's better to be thorough and write a little bit extra than to try to be fast and cheap with your writing and forget things. All right? Okay. Let's see here. First step. Right? 4r to the fourth divided by 2r squared. 4 divided by 2 is 2. R to the fourth divided by r squared. Remember, 4 minus 2 is 2, so 2r squared. And then back multiply. 2r squared times 2r squared. 4r to the fourth. 2r squared times negative 1 minus 2r, minus 2r squared. And subtract everything. Now, I'm going to change this in a second, but I want to show you. 4r to the third minus the minus 2r squared, these are not like terms. Same variable, different exponent. Okay, that's why I'm saying you got to be really, really careful when you're combining like terms and when you're doing subtracting. So what I'm going to do, to make things look nice and organized, instead of putting my r squared there, I'm going to put it over here. And now my r squares line up. And that's why I put this placeholder so I could have things that looked a little bit more organized. All right, I wouldn't forget things. So 4r to the fourth minus 4r to the fourth is 0. 4r to the third minus, there is no 4r to the third, so it just stays the same. 0 minus the minus 2 is plus 2, r squared. And then bring down the rest. Okay, let's do the next one. 4r to the third divided by 2r squared. 4 divided by 2 is 2. R to the third divided by r squared is just r. Now back multiply. 2r squared, or 2r times 2r to the third is 4r to the third. 2r times negative 1 is negative 2r. So I'm going to put it over here with my common or like term. And what do? We subtract everything, right? That was my impersonation of my students. They sound like Pete. Anyways, so we get 0 here. We have 2r squared, right? 2r squared minus nothing is itself. 8 minus a minus 2. 8 plus 2, right? Minus a minus is plus. So 8 plus 2 is 10r plus 3. Ooh, we're getting close. All right, 2r squared divided by 2r squared. So help me if you don't know what that is. Oh, I thought I accidentally paused my video. Is 1. Anything divided by itself is 1. Okay, 3 divided by 3 is 1. Negative 700 divided by negative 700 is 1. X divided by x is 1. Okay, dogs divided by dogs is 1. Anything divided by itself is 1. Because you can only make one group. Right? Anyways, now back multiply. 2r squared. 1 times negative 1 is negative 1. I'm going to put over here at my constant. And we subtract everything. 2r squared minus 2r squared, that's 0. 10r minus nothing is 10r. 3 minus a minus 1 is 3 plus 1, so plus 4. Okay. Now, if you look at the degree here, or the exponent of your r. It's a 1. Look at your degree here. It's a 2. We cannot divide any further because this is smaller than your divisor. So this right here is our remainder. Okay? When the degree of your remainder, or what you might think is the remainder, or what's right here, is smaller than the degree of your divisor, you're done. That's your remainder. Okay? So, how we write a remainder? Okay, we don't write r dot this. Okay, that's for small children. Okay? Elementary kids. We're going to write it correctly. So we're going to, when we divide, we have this and, okay, so when we divide this polynomial by this polynomial, we come out with this and a remainder. Okay, when we say and in math, we mean plus. Okay, now this is technically, look, it's still inside the obelisk here, right? It's still being divided. So this is still being divided by this. So 10r plus 4 divided by 2r squared minus 1. Boom, done. That's your answer. This is how we write the remainder for polynomials. Okay. So once again, the remainder is still inside the obelisk. The remainder is still being divided by the divisor. So we write it, remainder divided by divisor. Okay. Honestly, logically, it really makes sense, right? It's kind of simple. Logically, it makes sense. What's inside the obelisk, what's being divided by what's doing the dividing. So we just write it like that. What's being divided by what's doing the dividing. Okay, dividend divided by divisor. Ooh, that's a lot of Okay, let's get into our synthetic division. Like I said, synthetic division is quicker, but you can only use it in certain instances. Okay, so 4n to the 4th plus 8n to the 3rd minus 4n squared minus 48n minus 18 divided by 4n minus 8. Okay. Now remember I said synthetic division. You must divide by a linear binomial. Okay, 2 terms. Binomial. Linear, the biggest exponent is 1. And you have to divide by a 0. So we need to find the 0 of our divisor. So we're going to set it equal to 0. That's what 0 means. Set it equal to 0. Remember last year when you solved by factoring, you should remember, when you solved by factoring, you set it equal to 0, and that gave you the x-intercepts where y equals 0. You keep hearing the word 0. Okay, that's why it's called a 0. We're going to solve for n. We're going to get n by itself. 2 is our 0. 2 is our 0 that we're going to divide by. Okay, now I'm going to show you how to set it up. We're going to do an upside down obelisk. Upside down obelisk. We're going to divide. Our divisor is going to be our 0, so 2. Okay. And then we're going to put the coefficients in our divisor, or excuse me, in our dividend. That's why we needed the 0, because we don't want any variables. We're using the 0, and so we're only going to put coefficients. Now, extremely important. It must be written in standard form. Okay, if you were in my class last year, which I don't think a whole lot of you were thinking about it. I guess it might go well, or not so well for you, right? No, it's gonna. No. Forget what I said. Standard form. I forced you to write in standard form always because I knew you were coming to SM3 and you needed to write in standard form. Okay, it wasn't going to be an option anymore. So standard form is your polynomial written from biggest exponent to smallest exponent. So from 4, 3, 2, 1, no exponent. All right, so this is standard form. We're going to put our coefficients in standard form. 4, 8, -4, right? The signs go with the number, always. -48, -18. That's how we set up synthetic division. We bring down, okay, our leading coefficient here, our first number. So it's a little bit opposite of long division. Remember long division, the last thing we did was bring down. Here, the first thing we're doing is bringing down. Okay? And then right before bringing down, we multiplied. Now we're going to multiply. 2 times 4 is 8. And we're going to perform the sign. So this is a positive 8, so we're going to add. 8 and 8 is 16. Multiply. 2 times 16, 32. -4 plus 32, or 32 minus 4, is, what was that, 28? Two times 28 is going to be 56. -48 plus 56, or 56 minus 48, should give you 8, right? Two times 8, 16, -18, plus 16, -2. That's our remainder. Okay. Now you might be thinking, well, okay, so we divided, but what do all these numbers mean? Okay. This is actually our polynomial. Okay, this is our quotient. We just did n to the 4th divided by n, correct? N to the 4th divided by n. So our biggest degree, or our biggest exponent, or our degree, should be n to the 3rd, right? N to the 4th divided by n is n to the 3rd. So this is 4n to the 3rd. Or, if you want to think about it this way, because we can only divide by a linear to the first power, our polynomial is always going to be 1 down from this. So 4 minus 1, 3. Okay. And then this one is just the next step down. 16n squared. Next step down, 28n. No variable, right? This is 0, exponent of 0. And then our remainder, plus -2 divided by, what did we divide by? 4n minus 8. Now, if you want to simplify this, you should. Okay, this right here. I'm not going to harp on it too much this year because everything is online, and I'm more worried about you getting synthetic division and simplifying that little piece right there. But you should practice it. Divide top and bottom, or numerator, denominator by 2. You get -1 over 2n minus 4. You could also write it like that. If it confuses you, it's okay for now. You don't have to worry about it. But this is our answer. Okay, now I can't really go in too much this year, and I don't really go too much into it any other year either, but especially this year because of time constraints. Can't go into too much of how it works. So I guess this year I'm just going to ask you to trust me and that it does work. But when in doubt, long division. So you can check yourself. If you want to check and see if it actually does work, then use long division with this. Okay, but we're not going to do that right now because we're at 30 minutes. Okay, so I'm going to do another one with you, another synthetic division, and allow you to practice. Okay. Now remember, if you have questions for me, I'm here after school. Okay, come ask questions. I will wear a mask, I promise. So I won't get you sick. I'm not sick. Negative 33 minus 24 z squared plus 6z to the fifth minus 58z plus 7z to the fourth divided by 7 plus 6z. First things first, is this in standard form? No. Right? It needs to be written from largest exponent to smallest exponent. So we're going to rewrite 6z to the fifth. Okay, that one's done. Plus 7z to the fourth. Done. We don't have any z to the thirds, right? But we want a placeholder. Remember, we want to use our placeholder. Plus 0 z to the third minus 24 z squared minus 58 z minus 33. Okay, there's our standard form. Now, we want to divide by a 0, correct? Long division by a factor, synthetic division by a 0. So we take our divisor and set it equal to 0. So 7 plus 6z equals 0. Okay, minus 7 for both sides. Divide by 6. Our favorite. We got a fraction. And it's a negative fraction, which makes it all much more fun. Okay, so that's our 0. It's negative 7 over 6. So negative 7 over 6 is our divisor. We put our upside down obelisk. And then we write our coefficients in standard form. 6, 7, 0, negative 24, negative 58, negative 33. Now, with long division, I said you didn't need the placeholder. If you didn't want it, you just need to be careful with what you're doing. Synthetic division, you must. It's not you don't need to. You have to, or your synthetic division will not work. You have to have that 0 placeholder if you don't have one of the terms. So we didn't have any z to the thirds up here, so we have to have 0 in our z to the third column. Okay, there has to be that 0 placeholder. Okay. I'm going to say it one more time because I know there are some of you that it didn't sink in. If there is a term that you don't have any of, you must put a 0 as a placeholder in synthetic division. Here, we didn't have any z to the thirds in our original polynomial. We had to put a 0 as a placeholder between z to the fourth and z squared for our z to the third. Okay. Bring down the first term, leading coefficient. First number, I guess. Coefficient, excuse me. Multiply. Negative 7 over 6 times 6 is negative 7, right? Right. 7 minus 7 is 0. Negative 7 over 6 times 0 is 0. 0 plus 0 is 0. Negative 7 over 6 times 0 is 0. Negative 24 plus 0 is negative 24. Negative 7 over 6 times negative 24. Quick in your head, what is it? Negative or positive 28, right? Yeah. Positive 28. Negative 58 plus 28 is negative 30. Negative 7 over 6 times negative 30 should be negative 30, or positive 35. That gives us a positive 2. Negative 33 plus 35 is 2 as our remainder. Okay. Now remember, we started with z to the 5th, so now we should have z to the 4th as our answer, or in our answer. So 6z to the 4th. Now this is 0z to the 3rd, so we don't need to put it in our answer. 0z squared, actually I'm going to write it just so you don't get confused. 0z to the 3rd, 0z squared, minus 24z minus 30. We don't need to write this, so I'm going to simplify. 6z to the 4th minus 24z minus 30. Remainder of 2, so plus 2 divided by, what did we divide by originally? 7 plus 6z. And boom, we're done. So not too bad at all. Okay. And that's it for this video. Once again, because this is the first new content that you're learning, besides the review I put up, which you probably should review since it's been a summer. So if you have questions, make sure you come in and talk to me.